So question number 8, which equation below will allow only one solution? So there are 3 options that we have when solving an equation like this with only one variable. The first one being there's one solution. That's what we expect most of the time. And when solving the equation with one solution, you have a variable left to solve for. We'll talk about more about that in a second. The other option is you can have no solution, and your no solution answer happens when your variables cancel and it leaves you a false statement. So when you're solving this in the process, your variables cancel out. So your variables cancel and leave a false statement. What do I mean by a false statement? If I were to get a statement like 1 equals 5, well, obviously 1 doesn't equal 5, so my variables cancel. I'm left with a false statement. There would be no solution to that answer. The other scenario that could happen would be all real numbers, and that's when your variables cancel and leaves a true statement. So in that scenario, my variables would cancel out in the process of solving and leave something like 5 equals 5. That would be all real numbers. So for example, as we're doing letter A, if I'm solving this equation, what are my steps? Distribute? Okay, doesn't apply. Combine like terms on each side. I can't combine terms over here. I can't combine terms over here. So we're going to move all our variables to one side. I'm going to add x to both sides to get rid of minus x. I'm using inverse operations. I'm considering both sides of that equation. And when I add x to both sides, my variables cancel out. I have negative x plus x, which leaves me with no x's left over here. I have negative x plus x over here, leaves me with no x's. So I end up with 4 equals 4. My variables cancel. I'm left with a true statement. That would be all real numbers for letter A. Also, you also sometimes will see that with infinitely many solutions. That wouldn't be an uncommon answer for that one either. So all real numbers or infinitely many solutions. If I were doing letter B, it would be the same basic idea for the problem. And I would get my variables on the same side. So I'm going to add 3x here and add 3x here. And what happens when I move my variables to that same side? My variables cancel. If I have negative 3x plus 3x, I have 0 left. So there's no variable left to solve for. And notice I'm left with a false statement. 0 does not equal 9. That would be an example of no solution for that problem. And remember what we're asking for, though. We're asking which one of the ones below have one solution. So this one has infinitely many solutions, all real numbers. This one has no solution. As I'm doing letter C, if I want to get my x's on one side, I'm going to subtract 1/2 x from both sides. And that's going to result in variables canceling and leaving me with 0 equals 0. That would be another all real numbers solution. But as I'm doing letter D, if I divide both sides by 2 to solve for x, I get x equals, what would that be, 9.5 or 9 1/2, which has a variable left to solve for. That's your one solution problem. So your one solution problems, your variables don't cancel out. You're left with a variable that you can go ahead and do your inverse operations, solve it down, figure out what the answer to that equation is. That's your correct answer. There's only one solution to that problem, while there's no solution to this one, and there's infinitely many solutions to those two.